The river is already awake when the iron hull begins to move. Water trembles along its banks, reeds bending before any wave arrives. Deep inside the steel body, gears the size of cottages engage with a low, deliberate violence. Chains tighten, buckets descend. What had been a flowing riverbed seconds before becomes an exposed wound of mud, stone, and buried time. 6,500 tons of iron lean forward on floating pontoons, balanced not by grace, but by calculation. Each motion is slow, unstoppable, indifferent. Steel teeth bite into the river's spine, tearing away sediment laid down over 10,000 years. The sound is not a crash, but a sustained roar, metal grinding against earth, water choking as it is displaced, redirected, forced to obey. Men stand on narrow walkways bolted to the machine's flank, and their boots vibrate with every cycle. Steam hisses past their knees. The air smells of wet clay, hot oil, and rust. A single misstep would mean falling into the machinery's path, where nothing stops, nothing pauses, and nothing remembers names. On shore, survey markers wait in neat rows, flags marking future rail lines, future ports, future borders. The dredge does not see them. It only knows depth, resistance, and output. Tons per hour, yards per day. Rivers straightened, channels widened, mountains reduced to slurry and pumped elsewhere, out of sight, out of mind. This machine was not built to explore. It was built to erase, to redraw geography so empires could move faster, cheaper, and farther inland, to turn unpredictable water into obedient infrastructure, to make maps obsolete the moment they were printed. While the river fights back in small ways, currents twisting, silt clogging intakes, but the iron giant adjusts, recalibrates, and continues. It has deadlines to meet, contracts to satisfy, nations waiting downstream. By nightfall, the river no longer follows its old path, it follows orders. Progress arrived on rivers disguised as necessity. Coal needed ports, grain needed depth. Steel required predictable channels, measured in feet, not seasons. The iron dredge promised certainty where water refused it. By carving channels straight and deep, it freed commerce from delay and nations from dependence on tides. Barges moved heavier loads, railheads pushed inland, maps stabilized, ledgers balanced. Yet the same certainty carried a price that did not appear on balance sheets. Rivers were living systems, braided and shifting, dispersing flood and fertility across plains. The dredge collapsed that complexity into a single obedient trench. Currents accelerated, banks eroded, wetlands starved. What had once absorbed excess water now delivered it downstream with amplified force. The machine solved navigation while manufacturing new risks. For governments and investors, the paradox was tolerable. Economic growth arrived quickly, visibly, and in measurable tonnage per hour. Environmental cost arrived slowly, dispersed across decades and jurisdictions. The dredge's success depended on this asymmetry. It converted irreversible change into incremental profit. By the time consequences emerged, the contracts were complete and the crews reassigned. For workers, the contradiction was immediate. Employment meant proximity to power on an unforgiving scale. Wages were earned inside noise that never stopped and heat that erased time. Safety rules existed, but output ruled. Every pause threatened schedules tied to capital and politics. The dredge liberated labor from seasonal idleness while binding bodies to continuous risk. Engineers understood the trade. They spoke in tolerances and maintenance intervals, aware that rivers exceeded both. Designs compensated with redundancy and mass, trusting weight to overcome variability. When failures occurred, they were framed as anomalies, not signals. The system required confidence to proceed. The central question was never whether the dredge worked. It did. Rivers moved, mountains dissolved into slurry, empires expanded inland. The question was, who bore the instability displaced by that success? Or progress was achieved by transferring uncertainty from commerce to ecology, from ledgers to landscapes, from owners to operators. In this exchange lay the machine's power and its danger. The dredge did not merely reshape rivers, it reorganized responsibility, assigning permanence to profit and volatility to everything else. That reorganization was deliberate. Law followed engineering, redefining rivers as corridors rather than commons. Ownership extended outward from banks into moving water, enforced by permits and patrols. When floods arrived, blame traveled downstream with the surge. Insurance absorbed some loss, public works absorbed more, and memory absorbed the rest. Each intervention justified the next, locking societies into maintenance regimes that demanded perpetual motion. Stopping became unthinkable. Or to halt the dredge was to accept congestion, scarcity, and political backlash. Thus, momentum replaced deliberation. The machine endured not because it was perfect, but because alternatives were framed as regressions. In choosing stability for trade, uncertainty was exported to margins where resistance was quieter and accountability diffuse. Within this paradox, the iron giant became a solution that multiplied questions, advancing prosperity while narrowing the space to refuse its logic or escape its consequences for communities, ecosystems, and workers whose losses accumulated quietly beyond the machine's triumphant metrics and official reports written years later after channels hardened and normalized. Rivers had once defined the limits of movement. They flooded without notice, shifted their channels, froze, silted, and refused schedules. For agrarian societies, this volatility was a condition to be endured. For industrial states, it became an intolerable inefficiency. By the late 19th century, production had outpaced geography. Factories inland demanded raw materials at volumes rivers could not reliably deliver. Finished goods waited on banks while water levels decided their fate. Railways expanded rapidly, but steel tracks ended at rivers that could not guarantee depth. Transfers cost time, delays cost capital. Empires dependent on extraction faced a contradiction. Their resources lay inland, but their logistics remained coastal. Colonial administrators wrote reports describing rivers as barriers rather than lifelines, their curves wasting distance, their seasonal behavior undermining predictability. The language of nature shifted. Well, rivers were no longer described, they were diagnosed. Industrial competition sharpened the pressure. German, British, American, and later Japanese planners measured throughput and compared charts. A port that handled a deeper draft could dictate regional trade. A river that accepted heavier barges could determine which city grew and which stagnated. Strategic vulnerability was calculated in feet of water and hours lost to low tide. The river became a site of rivalry. War accelerated these calculations. Mobilization required uninterrupted supply lines. Coal, timber, ore, and food had to move regardless of season. Military planners demanded channels that could support standardized vessels and predictable transit times. Engineering firms found patrons willing to underwrite massive interventions. What could not be stabilized was bypassed. What could not be bypassed was rebuilt. Public discourse framed the effort as inevitability. Newspapers celebrated straightened channels as victories over chaos. Maps were redrawn to emphasize uniformity, smoothing bends into lines. The crisis was presented as technical, not political. Rivers were misbehaving systems in need of correction. The solution was scale. Dredging offered that scale. Unlike dams, which fixed water in place, dredges promised flexibility. They could move, deepen, and maintain. They did not merely create channels, they enforced them continuously. Sediment removed upstream was the same sediment that would return downstream. The machine's task was endless, and that endurance matched the needs of expanding states. Financing followed. Governments issued bonds justified by future tolls and increased trade. Private consortia secured long concessions. Risk was socialized, benefit was concentrated. Communities along rivers were consulted after plans were finalized. Compensation addressed property lines, not livelihoods altered by changed currents and flood patterns. By the time the Iron Giant entered service, the crisis it answered had been carefully constructed. Rivers were framed as failures of nature obstructing human progress. The dredge arrived not as an aggressor, but as a remedy. Its violence was administrative, its justification statistical. In that context, resistance appeared irrational, even dangerous, to those whose prosperity now depended on uninterrupted flow. The decision to build at unprecedented scale was not born from ambition alone. It emerged from spreadsheets, shipping tables, and forecasts that assumed growth as a constant. Smaller dredges had proven insufficient. They clogged, stalled, and demanded frequent relocation. Each failure reinforced the same conclusion. Capacity had to exceed the river, not adapt to it. Weight would become authority. Design meetings unfolded across drafting rooms, thick with smoke and calculation. Engineers specified bucket chains capable of lifting thousands of cubic yards per day. Hulls were widened to resist torsion. Pontoons were compartmentalized so the machine could survive partial flooding. Every line on the blueprint assumed motion under stress. The target mass, 6,500 tons, was not symbolic. It was derived from stability curves and projected output rates that left no margin for restraint. Materials arrived by rail in relentless sequence: rolled steel plates, cast gears. Boiler assemblies and miles of chain were staged along dry docks, converted into assembly yards. Riveting gangs worked in shifts, the sound echoing for miles. Each joint was inspected, chalk-marked, and logged. Delays were punished financially. Speed was rewarded. The cost eclipsed earlier projects. Funding combined public money and private guarantees, insulated by clauses that transferred environmental and social risk to the future. Political leaders attended launches, praising foresight and national resolve. Photographs captured the hull from low angles to exaggerate height and permanence. The machine was presented as infrastructure, not equipment. It would outlast administrations, perhaps generations. Once assembled, testing was brief. The river would provide the true trial. Boilers were fired, and the bucket ladder lowered for the first time. Sediment rose in a dark plume, confirming both function and consequence. Adjustments followed, gear ratios refined, discharge chutes reinforced. Within weeks, the dredge entered continuous operation. Its arrival altered labor markets. Skilled mechanics migrated to its wake. Unskilled labor was recruited locally, trained quickly, and exposed immediately. Housing sprang up near staging points. Supply chains formed around fuel, spare parts, and food. A moving industrial town followed the machine, transient but essential. As output increased, confidence hardened into policy. Contracts expanded the mandate. Rivers once scheduled for minor improvement were reassigned to total reconstruction. The Iron Giant became a reference point, its performance cited to justify replication or escalation. And scale redefined feasibility. In operation, the dredge erased the distinction between construction and maintenance. Each day's work anticipated the sediment of the next. This perpetual demand validated the investment. Stopping would concede defeat to the river. Continuation became proof of correctness. Thus, the machine's rise was less an invention than an institutional commitment. It embodied a belief that geography could be managed indefinitely through force and vigilance. In that belief, the Iron Giant found both its purpose and the expectations that would later test its limits. The Iron Giant's operation was a choreography of scale, precision, and relentless force. Its hull stretched over 300 feet, supported by pontoons that distributed 6,500 tons across water, too shallow for conventional vessels. And every structural component was over-engineered to absorb dynamic loads, from the repeated pounding of the bucket ladder to the torque of massive drive shafts. Engineers designed the dredge as a single system. Propulsion, excavation, discharge, and navigation integrated into one moving organism. Power came from twin coal-fired boilers, each capable of producing nearly 50,000 horsepower. Steam ran through a maze of pipes to drive giant engines that rotated drums, chains, and buckets with hypnotic rhythm. Each bucket measured 12 cubic yards, its teeth hardened to penetrate compacted riverbed clay. The chain looped over massive sprockets, the sound of metal on metal, a constant low-frequency roar that could be heard miles away. Timing was precise. A misalignment of inches could jam the mechanism, risking catastrophic failure. Buckets excavated the river in continuous succession. Material lifted was deposited onto a conveyor system, traveling hundreds of feet to discharge points on shore or into barges. Each motion required coordination between operators, engineers, and deckhands. Gauges monitored torque, hydraulic pressure, and chain tension, while inspectors traversed narrow walkways to detect wear invisible from the bridge. The dredge's efficiency was calculated in cubic yards per hour, and every second outside tolerance reduced overall output. Navigation demanded its own expertise. The pontoons allowed the dredge to float, yet offered little room for error. Shallow banks, submerged logs, and shifting currents threatened stability. Pilots used draft charts and lead lines alongside visual markers, guiding a machine whose mass resisted both hesitation and sudden correction. Adjustments occurred gradually. The dredge could not turn sharply. It had to be coaxed, persuaded, and sometimes forced into position. Crew life revolved around this mechanical rhythm. Operators communicated with whistles, bells, and hand signals, while engineers monitored engines in stifling heat. Lubrication required constant attention. Chains stretching under load could snap violently. Boilers could overpressurize. Pontoons could list if sediment accumulated unevenly. Every system was interdependent. A failure in one sector propagated, threatening the entire operation. Redundancy was engineered into critical components. Spare chains, gears, and hydraulic parts were stored on board. Crews rotated in shifts to maintain alertness, knowing that fatigue could not be tolerated when millions of pounds of iron were in motion. Repairs often involved working in confined spaces, in steam and grime, while the rest of the dredge continued its relentless excavation. In total, the dredge operated as both machine and ecosystem. Its scale amplified consequences. Small errors became structural threats, delays rippled downstream, and mechanical mastery defined success. The Iron Giant was not merely a tool, it was an industrial predator, each motion deliberate, destructive, and transformative. Despite its imposing scale and precise engineering, the Iron Giant carried vulnerabilities invisible at first glance. Its weight, distributed across pontoons, depended on uniform sediment beneath the riverbed. Uneven compaction, hidden boulders, and sudden washouts introduced stresses beyond design tolerances. Engineers calculated margins assuming predictable conditions, but rivers were rarely so obliging. Each dredging operation amplified subtle instabilities that, left unchecked, threatened hull integrity. Chains, though reinforced, stretched under constant load. Bearings heated beyond specifications. Boilers ran near maximum pressure. Maintenance schedules assumed compliance with idealized wear rates, yet in practice, abrasive silt accelerated deterioration. Failures were not immediate. They emerged gradually, concealed by the scale of the operation and the noise of normal function. A minor alignment error in a sprocket could propagate through the bucket chain, increasing strain elsewhere, ultimately endangering the entire excavation system. And the dredge's environmental impact was similarly underestimated. By forcing rivers into straightened, uniform channels, sediment deposition patterns changed, altering downstream currents and eroding banks. Floodplains were starved of silt, wetlands began to disappear, and fish populations collapsed in sections where excavation intensified turbidity. The machine transformed the river from a resilient, adaptive system into a brittle corridor of controlled flow. Every engineering triumph produced ecological debt, accumulating silently and predictably, yet largely unmeasured. Operators understood danger intuitively. The creaking of pontoons, the vibration through walkways, the way water shifted against hulls, all suggested stress. Yet production schedules demanded continuity. Halts were costly, politically and economically. And the machine's sheer mass instilled confidence, masking early warning signs that would be unmistakable in smaller dredges. Hubris, in combination with necessity, blinded decision-makers to the latent threat. Some engineers proposed reinforcements, thicker hull plates, additional bracing, slower cycles, or redistribution of load. These suggestions were often dismissed. Delays were unacceptable. Rivers waited for no design change. Iron confidence outweighed caution. In doing so, the dredge became a paradox, both solution and source of future failure, a monument to efficiency that contained the seeds of collapse. Human error compounded the structural vulnerability. Crews, fatigued by relentless work schedules, occasionally bypassed inspection protocols. Lubrication might be skipped, minor cracks left unreported, and an early signs of wear tolerated in the interest of output. In combination with environmental stressors, these lapses accelerated the onset of critical failures. The hidden flaw of the Iron Giant was thus not a single weak point, but a network of limits, material thresholds, environmental miscalculations, and human constraints intertwined. The machine's power was inseparable from its peril. Every cubic yard lifted, every river straightened, brought the system closer to an inevitable reckoning, a reckoning that would test not only metal and mechanics, but the resolve and lives of all who served upon it. Life aboard the Iron Giant was defined by unrelenting rhythm and constant vigilance. Crews lived, labored, and survived within a metal labyrinth that stretched over 300 feet. Walkways, narrow and slick with oil and water, and threaded around boilers, gears, and conveyor belts. One misstep could result in a plunge into rotating buckets, steam-scorched decks, or the murky river below. Yet despite the omnipresent danger, men and boys moved with practiced precision, their bodies attuned to the cadence of the machine. Shifts were measured in hours that blurred into days. Operators watched chains, loop, and buckets lift, repeating motion cycles thousands of times without pause. Steam hissed from pressure valves, hot oil dripped from greased bearings, and vibration traveled through steel and bone alike. The smell of soot, wet clay, and metal dust permeated everything. Meals were hurried, often eaten while monitoring gauges or clearing minor jams. Sleep was taken in hammocks slung between structural beams, swaying slightly with the motion of the dredge. Always ready for alarms or sudden shifts, hierarchy governed every action. Senior engineers dictated timing and sequence. Deckhands relayed signals, monitored minor wear, and executed orders. Apprentices learned quickly, often by observation, occasionally by accident. Knowledge of the machine was both power and survival. Each role carried responsibility. A misread gauge could cascade into equipment failure or human injury. Communication relied on a combination of hand signals, whistles, and shouted instructions, sometimes over the roar of moving iron and rushing water. Fatigue was constant. Muscles strained to manipulate tools, valves, and chains. Eyes adjusted repeatedly to smoke, steam, and shadow. Mental focus was a commodity, continually depleted by heat, vibration, and danger. Injuries were common: burns from hot metal, elacerations from chains, fractures from slips. Yet the dredge demanded endurance. Even minor lapses in attention could halt production, compromise safety, or damage the colossal mechanism. Crew camaraderie existed, but was forged under stress. Men developed intimate knowledge of one another's reactions, anticipating movements, understanding rhythms. Trust was literal, for survival depended on the coordinated operation of the machine. Alone, each worker was expendable. Together, they became extensions of the dredge's mechanical will. The human body merged with iron, not seamlessly but necessarily, producing a living component of industrial purpose. Social life off the dredge was limited. Temporary housing clustered near operation sites, lacking comfort or permanence. Alcohol and fleeting leisure were the few escapes, though never from the awareness of danger. The work dictated identity: operator, engineer, deckhand. Each man carried the imprint of the machine, its noise embedded in hearing, its motion in muscle memory, its risk in every heartbeat. Through this immersion, it became clear that the Iron Giant did not merely move rivers, it redefined the rhythm of life itself. Time, labor, and mortality were subordinated to its operation, and those who worked within it were bound to the relentless pulse of industrial necessity, their existence inseparable from the colossal mechanism they served. The inevitable reckoning arrived quietly at first, as subtle misalignments rippled through the Iron Giant's vast frame. Chains stretched beyond their intended tolerances. Bearings squealed under load. The river itself seemed to resist, surging in unexpected eddies, swirling sediment against pontoons, and lifting scour near the hull. Operators reported vibrations they had learned to ignore, but these signals were precursors, warnings embedded in the very mechanics of the machine. Then, one morning, the dredge encountered a hidden boulder larger than any previously surveyed. Buckets jammed mid-cycle, sending torsion through the bucket ladder. The hull shuddered, pontoons listing slightly. Steam valves hissed violently, pressure spiking in the boilers. For a moment the massive machine paused, caught between motion and stillness. Workers scrambled along walkways, chains rattling under stress, sweat and grime mingling with oil. Each second stretched into eternity. Attempts to dislodge the obstruction compounded the stress. Operators reversed chain direction, Engines strained against resistance, and emergency brakes engaged partially. Metal screamed, bolts sheared. The dredge's body seemed to convulse as force met immovable mass. Crews moved like shadows, anticipating mechanical shifts and reacting to unseen threats, their lives measured in inches and milliseconds. Outside, the river did not wait. Currents, now redirected by previous dredging, pushed against the partially immobilized hull. Banks eroded under new pressures, water lapping against floating supports with increasing intensity. Onlookers on shore, surveyors, engineers, and labor overseers watched in horror and awe as the massive machine writhed, a living beast caught in its own momentum. The crisis escalated when part of a pontoon gave way. Water flooded compartments previously thought secure. Emergency pumps engaged, but the inflow exceeded their capacity. Crew members shouted warnings, signaling those still aloft to evacuate to higher walkways. Some disregarded safety, driven by the imperative to protect equipment. Others obeyed instinct. Chaos coexisted with precision. Orders cut through panic, yet nothing could fully contain the consequences of failure. The culmination was simultaneous: mechanical stress, human risk, and environmental disruption. Sediment clouds expanded downstream, altering the river's flow within minutes. Nearby bridges felt tremors as the dredge heaved, while debris threatened auxiliary craft. Injuries occurred: burns from ruptured steam pipes, bruises from shifting chains, fractures from slips. Miraculously, fatalities were limited, but the scale of damage was undeniable. By the day's end, the dredge was stabilized. Yet the episode left clear evidence. Even a super machine, engineered for dominance, remained vulnerable to unpredictability. The confrontation revealed that efficiency and scale carried inherent risk, that the relationship between operator, machine, and environment was delicate, and that every triumph depended on constant vigilance. The Iron Giant, though surviving, had demonstrated its limits. Its power was absolute in performance, but finite in resilience. The disaster, narrowly contained, would echo through engineering decisions, labor practices, and policy choices for decades, marking a turning point in industrial perception of control versus consequence. The aftermath of the Iron Giant's operation extended far beyond the immediate riverbanks. Altered currents reshaped landscapes downstream, eroding fertile soils and redirecting sediment that once nourished floodplains. Wetlands shrank as deposition patterns shifted, transforming habitats that had supported fish, birds, and small mammals for centuries. Aquatic ecosystems collapsed in sections subjected to relentless excavation. Species once abundant became scarce, and the ecological balance that rivers maintained naturally was replaced by a brittle, human-engineered uniformity. Communities along the river experienced disruption as well. Fishermen found nets torn and catches diminished. Farmers discovered arable land washed away, replaced by silt bars or submerged trenches. In towns where ferries had once facilitated trade, crossing points became unreliable or dangerous. The social cost of industrial advancement was immediate but dispersed, subtle, cumulative, and difficult to quantify in the ledgers that celebrated tonnage moved per day. Economically, the Iron Giant's influence was transformative. Railways extended into previously inaccessible areas. Raw materials, coal, ore, timber, flowed uninterrupted to industrial centers. Ports expanded as dredged channels accommodated larger vessels. Cities along the river grew, markets flourished, and empires consolidated power inland. Investment in infrastructure became self-reinforcing. The more the dredge enabled, the more funding it secured. In effect, The machine reshaped not only the land, but also the flow of capital and labor. Institutions adapted to the machine's influence. River commissions, engineering bureaus, and bureaucracies expanded their oversight. Maintenance schedules, emergency protocols, and monitoring stations were established to anticipate failures before they became catastrophic. Policies emerged to legitimize the dredge's interventions, extending governmental authority over waterways and codifying human dominion over natural systems. Yet this dominance carried risk. Straightened channels increased flood velocity, transferring hazards downstream. Infrastructure dependent on the dredge's continuous operation became vulnerable to stoppages, mechanical failure, or labor unrest. A single breakdown could cascade through trade, transport, and local economies. The system itself became a delicate balance held together by engineering mastery, human endurance, and continuous vigilance. The Iron Giant's systemic legacy was thus dual: immense, visible gains in mobility, commerce, and industrial expansion, coupled with hidden and ongoing consequences for ecology, communities, and regional stability. The machine did not merely excavate, it reorganized the environment, society, and economy, producing efficiencies whose benefits were immediate and quantifiable, while the costs were deferred, dispersed, and often invisible. In this complex aftermath, the Iron Giant transcended the role of tool. It became a force that structured both nature and society. Its presence demanded adaptation at every level: political, ecological, and human, embedding its influence into the rivers, the land, and the collective consciousness of the societies it served. Progress and peril had become inseparable, each defined by the relentless operation of steel and iron against time and terrain. Decades later, the Iron Giant rests in sections along riverbanks. By its hulking frame, partially dismantled, partially submerged, yet impossible to ignore. Its legacy is carved into the land. Channels it once straightened remain permanent, sediment flows redirected, banks reinforced, tributaries rerouted, wetlands lost, and flood patterns altered, testify to a human intervention that outlasted those who designed, operated, and maintained the dredge. Nature remembers, but it remembers differently. Faster currents, deeper channels, and landscapes that now obey calculations rather than seasons. The human imprint is equally enduring. Former workers tell of lives measured not in hours, but in cycles of buckets, gears, and steam. Communities developed around dredging sites, their economies pivoting to accommodate the demands of the machine. Families depended on wages earned inside heat, noise, and constant risk. Oral histories preserve the memory of courage, endurance, and loss, yet much has been forgotten. The names of those who perished or suffered injuries often appear only in scattered records, overshadowed by the grandeur of production figures and the achievement of engineering. Industrial practices were reshaped in its image. Subsequent dredges emulated scale, power, and continuous operation. Engineering manuals cited its successes, while failures informed safety protocols and environmental assessments. Maintenance regimes, labor shifts, and inspection routines evolved, integrating lessons learned from both triumph and calamity. The Iron Giant became a reference point, a standard against which all future river engineering would be measured. Yet beyond mechanics, the dredge left a moral and philosophical imprint. Its operation exemplified a paradox inherent in industrial progress: immense capability paired with latent fragility, a liberation entwined with destruction. Economies expanded, rivers yielded, empires extended influence, but only by transferring instability into ecological systems, communities, and individual lives. The lesson was subtle, observed in sediment patterns, flood scars, and worker testimonies, yet powerful in retrospect. Industrial power reshapes the world, but it also reshapes responsibility. In reflection, the Iron Giant stands as both monument and warning. Its steel and iron once dominated rivers, yet its legacy is neither total victory nor total failure. It represents the delicate balance between human ambition and environmental reality, between mechanical mastery and inherent limitation. Its channels still guide commerce. Its displaced sediment still reshapes floodplains. And its stories still echo in the memories of those who toiled within its bowels. Ultimately, the Iron Giant illustrates a truth about industrial civilization. The machines we build to conquer the natural world also construct our moral and historical landscape. Progress is measured not only in cubic yards lifted or kilometers straightened, but in the long shadows cast on people, ecology, and future generations. The dredge's power was absolute in its moment, yet its consequences endure in ways that no calculation, contract, or blueprint could fully contain. Steel reshaped the earth, and in doing so, reminded humanity of the cost inherent in commanding nature at such scale.